Good afternoon, guys. Welcome to the second session of TEAS. So first of all, welcome to the plane again. So our IETF not well, so you are reminded that if you contribute here, you will follow the IETF procedures and policies, and that if you are aware of any patent, please disclose it using the IETF rules or refrain for participating. So here you have all your VCPs. So we can remind you that the link is different from the previous session. Okay, so you need to log in again. Okay, so remember, if log in again. Okay, and if you need to go to the mic, click on the button. Okay, so here for the discussions, when they become heat, okay, just don't go directly to the mic. Okay, just click the button. Okay, so now let's go to the speakers, and the first one, Bo. Okay. This one.
Number 10. Number 9.
Number 9. Wait, but there are 2 9s.
So go to the second one.
Second one. This one.
Hello, everyone. Good afternoon.
A little closer. I'm sorry.
Okay. My name is Bo, and I'm here to give some status of these 2 NRP young modules merging status and some open issues where the author is facing. And we'd like to hear some feedbacks from working group. I'm sorry that I haven't listed out all the authors of the 2 drafts, but we feel grateful of all the authors' contribution. And just a brief background on these 2 NRP young modules. NRP stands for Network Resource Partition. If you still you're familiar with Network Slice Framework draft, you will see that networks resource partition can provide some resource partition from the underlay network. And so the NRP policy draft and NRP young module, the 2 drafts try to define the different function of NRP attributes, but sometimes they use similar set of constructs. So we get the feedback from working group, so we are doing the merging of these 2 drafts. So the authors of 2 drafts have the grade to produce a new merged draft. The name I put in here is that the authors are unable to publish this draft before this meeting. But our goal is to define a single NRP young draft to covering both the NRP network model and device model. And for the NRP model, we can also cover several operations of this NRP, including instantiation, modification, and also monitoring, so that the slice service can doing the automation of this service provisioning. Next slide, please. So here I give some progress of what we made to these merged drafts. On the right, you can see that this NRP module has 3 parts, 3 major parts. The first is NRP instantiation. The second is NRP monitoring, and the third one is NRP device. But our decision is that we first touch about the NRP installation of monitoring that belongs to a network model. And when these 2 has been stable, we will select some attributes from this two, and then we will reuse in the NRP device definition. And for NRP installation definition, this part we major borrowed from the NRP policy module, and we augment with additional attributes for IGP congruent and also another options of direct topology option rather than the filter topology defined in NRP policy. Here I like to give some more information about NRP policy, why we use it, because NRP policy specify the topology associated with NRP and also specified how resource partitioning, like what bandwidth belongs to this NRP and what kind of SLO mechanism can be realized in this IPMPS network. And also, if you remember, the NRP policy defines 3 modes of partitioning. One is data plane partitioning and control plane partitioning, or it can both 2 modes. And NRP monitoring definition, this part mainly borrow from NRP model. We are still under discussion. And the device model, I just mentioned this, we will get to that part when we fixed on the NRP definition. So next slide, please. I noticed Greg has some, so I'm not sure you have some comment on this part.
Yes, thank you for your kind consideration. Greg Mirsky, Ericsson. So if I understand correctly, the blue color depicts a separate Yang module.
Not separate one. I just mean the separate parts,
Oh,
not the separate
okay.
one.
Okay, because
But I can clarify that device model and network model may belongs to different module.
okay.
Yeah.
So I would just probably would suggest you consider that performance status and resource utilization, there might be not specific to NRP and might be presented as a separate module, especially because performance status, if you are reflecting certain SLOs, and because something that we can discuss offline as part of the work on precision availability metrics, because precision availability metrics is about monitoring service level indicators for conformance to SLO. And that's, I think that would be something that will be commonality between the NRP and availability metric.
Yeah, our consideration is that this NRP network may, like each one will be subset of the underlay topology. So depending on that, there'll be like each NRP instance may have its different.
I think that when we talk about performance metrics, then it's technology independent. It doesn't really, it's more categorization of what underlay provides to the service. So basically, we're talking about certain units like packet loss ratio, delay, inter-packet delay variation. So it's not technology specific or network specific. It's basically abstract.
Yeah,
but
we
let's
understand it. Let's discuss.
Yeah, that's something because I think that will be beneficial if we can reuse modules.
Okay. Then here's the, I just mentioned about the different parts. And this NRP selector, I think Chair Pavan just mentioned about the NS IPMPS draft change. So that flow aggregator now changed to NRP selector. This selector definition is actually used in data plane partitioning mode. It's used to identify NRP specific forwarding resources. This can be defined as a dedicated or derived. And we here we try to model all those different encapsulations, IPv6, IPv4, and SR, MPLS. For MPLS part, the authors think the MPLS network action specific option has been defining. So the authors noticed this and will be modify this based on the progress of relevant work in MPLS working group. Please, Greg.
Hi, Greg Mirsky Erickson again. So while there is a M&A use case document, so it only specifies for now is that in relation to the network slicing is to carry global identifier. I think that it will be beneficial if you see that there is a need for additional use cases related for MPLS network, so that present it to the working group, because so far I'm not aware of any additional use cases relevant to network slicing.
Maybe Chair, yeah.
Quick response. Whatever is specified in the M&A requirements document, where they talk about having a global identifier carried around, that it's the same. That's
okay. So basically, there is only one use case that you see related to global identifier.
Yeah.
Okay.
And there is a draft that yeah. I mean,
Yes. Yes. It's already part of the working group adopted draft on M&A use cases.
Yes, I noticed that. Yeah. Okay. Next slide, please. Then another option. This is the other last one. Open issue that we have the model right now has PHB profile definition because we follow the NS-IPFS draft definition. But the authors, during the discussion, we have two concerns. One is that network slice arrays model defines some like standard profile and customers profile on the QS policy. And the other is that, and also layer 3 SM or LAX network model also use a QS profile. So we here's we like to collecting the feedback from the working group is that first is naming consistency between these profile definition, and then other is that whether we should provide both options in this NRP model. So next slide, please. So I think this is the most status of this draft, and we promise to publish the merge draft in this week. And after that, we like to ask working group adoption, and then we will continue working on the resolved item. Thanks.
Okay, thank you very much. I'm looking forward to see the merge document.
Yeah, okay.
Is it Iowa?
Hello, this is Iowa Guo from FutureWay, and I'm presenting a new draft IETF network slice topology on behalf of other co-authors and contributors. So basically, we defined a network slice topology model because of the motivation that for a network slice, it can ask for some certain level of customization when a network slice, when a connection within a network slice is being laid out. For example, we wanted to create a customized path across a topology of network, right? So we believe that a network slice can benefit by using a customized topology for resource reservation and sharing among different connections. And we call this type of network slice topology as a network slice topology. Next page. Yeah, so basically there are two points that to be specified for this type of topology. First of all, is that this network slice topology is representing a customer's intent, and it's not like other topologies which are exposed by the provider to the customer. And second point is why we wanted to go for a new topology is because the existing topology models like network topology or even the T topology module, there are some parts that are missing. For example, there's no customized SLO, SLEs that represents a intent from the customer. So we believe that it might be better to create a topology with all the SLO, SLE defined for the customer. Yeah, so basically when we look at the existing data models, there's this existing model called DraftLoo, with like an early version of that model that could be suitable for this purpose. However, yeah, if you go to the next page, the original DraftLoo model has both a topology definition as well as a connection definition, which basically creates the perception that this model is sort of giving an alternative solution for defining network slices. And for this new update, so basically we sort of reposition this model to not make it like an alternative solution, but to make it a complementary model to the existing network slice MBI YANG, which provides an option for the user, for the customer to specify customized connections over a customized topology. So to do that, sorry, yeah, next one, previous one, the previous page. Right, so what do we do is we essentially imported all the common SLO, SLE attributes that are defined from the NS-MBI YANG model, and then apply them to the topology constructs like links, nodes, or TPs that are defined by this model. And also, we removed the augments within the old version of this model relating to the connectivity constructs because they're already covered by the NS-MBI. So, and also relevant text and diagram updates. So this kind of makes this model a complementary document to the existing NS-MBI. Next page. Yeah, so this is an updated model relationship diagram as of the start of this IETF session. So we had a side meeting before this session, and there will be some updates probably which we will make when we reach an agreement for using this model. But essentially, what this network slice topology model is doing is it augments the base RFC 8345 and with additional SLE attributes, and then this model could be used by the network slice model, the NS-MBI, as well as for OTN technology specific slice model. Next page. Yeah, so the next two pages are just to show the model tree, and as you can see, the key point is just like it's building a network topology by adding the SLO, SLE templates to each of the topology constructs. Next page. Yeah, that's the same for link and TP. Okay, so yeah, that's yeah. No, the last one. Oh, okay. Next page. Right. Okay. So a couple of open issues. The first thing is the current NSMBI model has reference to a customized topology ID, which is just a reference to a topology identifier. So what we are thinking before this meeting is if we only reference a topology without indicating how this topology could be used by the network slice, by the connections within the network slice, then it probably it's missing its purpose. So either we add a topology ID, and also we add the for example, the explicit path for each of the connections within the network slice to show how the connection is routed over the customized topology. That's what we originally suggest. And after the side meeting, there's another interesting thought to basically to take out the customized topology entirely from the NSMBI and maybe put everything into this model. This is something that are still ongoing, and we will have some discussion, offline discussion around it, and settle with some points. Next page. The other open issue is there is a reference from the current NSMBI for each SDP. There is a reference to a TP termination point within a topology. So we are arguing whether the reference is from the SDP to the TP, or it's rather the other way around, that there is a reference from the termination point to the SDP, because it's possible that we could have multiple customized topology for each of the for different connectivity constructs within the network slice. One example is you could have one connectivity constructs that's optimized for delay, and the other connectivity constructs that's optimized for bandwidth. So they could use different topologies for this. And also a related question is whether an SDP exists before the LTP, the termination point, is created. So I think we can discuss this and resolve it offline. Yeah, so the next stop, we will try to resolve all the open issues and get some consensus among the authors and also with the NSMBI. And once this is done, we could request for a working group adoption. Yeah, I think that's the last one.
Pawan Biram as a working group participant. So in the slice service model, originally we said the higher in a case is for the client to not be requesting which topology on which the service would need to be placed. And then there was a use case that came out saying that we need to be able to specify, we need to have an option to specify the topology on which the service needs to be placed. So a pointer to a topology was added in that model,
yes.
Right? So I guess now there are existing ways of asking for a customized topology. I think what you're pointing out here is those are not sufficient, or those are kind of hard to use.
It's not like hard to use. It's just that, for example, if you wanted to figure out the SL, we need to associate the SLO with the topology constructs, which is not there.
In the interest of time, I'll probably defer my further questions. I'll talk to you offline, but
okay,
go ahead.
Okay, so we are gonna ask the working group whether you are interested in seeing that this particular work is brought into the working group. Just poll for interest, so please take your phones, and raise your opinion.
And while we're doing that, the next speaker should come up, and I don't know if it's Italo or Dan. Thank you. No matter what we get here, we're just getting a feel for the room, and of course, any adoption happens on the list. So we're running about 2 to 1. It's there's interest, but there's also opposition. So that's it. That's interesting. Thank you. Let me end it. Move to the next one.
Thank you.
I end it.
Hi, good afternoon. So I'm going to, what am I going to talk about? Yes, I remember. Right. So I'm following on.
Assurance.
Assurance, yes. I'm following on from the previous session when Italo was presenting the summary of the applicability of ACTN to POI. And as part of the development of that work, we identified there was a need to create another document, in fact, 2 documents. One was the pluggables that's going to be discussed later, and the service assurance. Next slide, please. So I believe, next slide, that Lou sort of raised a question earlier. So let's try to address that immediately, which is, why didn't we just talk about the service assurance requirements and potential architecture interfaces and models that may be applicable within the POI document itself, the one that Italo was talking about earlier? Well, actually, it's probably going to be much more complex than we originally anticipated, and therefore we didn't want to delay the previous document and take something which would not just typically fit in a subsection or even a main section and just try to sort of cram it in that document. Because when we started scoping this piece of work, and actually it potentially imports a framework from the ops area. So there's a service assurance framework that Benoit's been working on. There's a service assurance data model. Then there's technology specific data models that are currently being worked on, some of which actually serendipitously have been discussed this week. For instance, inventory management, blending in things like alarm, fault correlation. This suddenly actually becomes maybe complex is not the right word, but certainly a wider scope than would sort of fit with it, that would have fitted sort of nicely within that earlier document. So, Lou, so far from what I've just said, does that answer the question? We don't know yet.
Thanks. Even if the additions are complex, it's much easier from a process standpoint to have one document that is delayed a little bit than 2 documents that spend a lot of time in the working group. So we really need to see the text. One of the things that personally I didn't like when I started reading it is I saw a lot of duplicated text. Right. So that immediately says, why do we have this? And so I'd say is in the next version, remove any duplicated text and say, see this section. And then that'll allow us to really judge how much is novel in it. But in its current form with that cut and paste, it really feels like cut and paste. It's not working for me. I can't say for others.
Good. Italo. Sorry.
Yes, okay, I agree. We may remove the duplicated text and reference. My concern is that if we keep adding, because the scope may explode, and if you keep adding, we will never finish. And also when I see also in other cases, when it's becoming a too big document, then we can comment, oh, it's too big, it's too complex. So it's better sometimes to cut into small pieces rather than have a big piece. But I fully agree with you, no duplication of text is desirable.
Thank you.
Yeah, and you're right. We've been here before. Sometimes we break documents apart. Sometimes we combine them, and it's really hard to talk in abstract. It's really easy when it's very specific text. And I think the problem right now on this one is the duplicative text.
Yeah.
But
The meat is still missing, yes.
Perfect, thank you.
If it's okay, I'd like to hold Daniele's question for the end of the presentation. Next slide, please. So we use the same, essentially the same use case, the same architecture. So again, there may have been some duplication there. That's just sort of laziness on our part, so we can make sure that that is addressed. There are sort of several elements to service assurance, and we want to reuse what's already defined in the IETF, not importing anything from TMF or MEF or OIF or some other organization. This document will be a really useful piece of work to show the reuse of existing work, ideally that's published as an RFC or at least a very stable and mature working group document. But we have seen this week already that there are a few elements that would support service assurance that are very immature in the IETF. So your delay may be relative in this case, but we're not looking at potential months, especially as there's a new working group being formed and looking at the milestones and the charter. It could be several months, but that aside, next slide, please. You're right. It's a very simple document currently without a lot of substantive detail. We can issue the new version of the document and then make a decision, because we should have a better idea on timeline for some of those elements around inventory management, fault correlation, alarm correlation, etc. Maybe some OAM. There's discussion on sort of schedule OAM, which is very important. Actually, when you set up a service, you'll get the equivalent of a sort of service activation certificate or birth certificate for the service, to plagiarize some discussion from Victor earlier, and ensuring that you're proactively monitoring that connection, and then in the event of some catastrophic failure, you're having to switch over or and then restore the service, and then look at inventory management, and then handle change management as well. These are kind of quite complex things that may just simply bloat the existing document. But we can make that decision when we have more evidence that would help support whichever way we want to go. Next slide. That may actually be it. Yeah, I think we can leave the backup. It's just some generic slides. Cool. So Daniele.
Mine is not a question. I wanted to support what Italo was saying. We had a similar issue in CCamp. We had the transport NBI document, which was growing, and now we are spending a lot of time to put it on a diet. So I think in this case is a good idea. Also, if you have read the draft, this is a little bit more than a placeholder. We thought it was useful to show the diagram with the relationship between the different drafts. So that's a little bit more than a placeholder, while the other document is pretty stable. And a part one issue, I don't think that there is the need to do anything else. So in this case, I would keep the documents separate, because the level of maturity is completely different. And in CCamp, we learned that growing documents too much could be harmful.
Hi, Daniel. You raised the issue at the very beginning, but you touched it slightly. What steps are you taking also to with ops? Because this is the service assurance by Benoit. So how are we aligning with that work?
Yeah, so that's a really good point. I think we need to be practical first of all. So we need to look at the existing way that operators design, then activate, and then manage those services. So there are sort of several, well, maybe not several, but certainly 2 or 3 documents that are fairly mature that we will reference, and we may sort of import architecture and interfaces and point to specific Yang models. We will likely, hopefully, when we've got a more substantive document, let the ops area working group know that the work exists, maybe even present something to actually show them, actually, guys, thank you very much, boys and girls, we are using your work and others. We will probably have to avoid some of the things maybe around digital twin, digital mapping at the moment, just because it is sort of further sort of time horizon that I think this document needs to look at.
Thank you.
Okay.
Not ethical engineering.
Okay, we're going to jump a little bit out of order to accommodate some online people. So we're going to go now to Adrian, which is number 13.
Okay.
Hello, that was confusing. I'm not online, I'm here. We did some stuff at the hackathon, and the chairs asked me to prepare one slide. So I prepared 2 slides, but I was expecting 2 minutes and I got 10 minutes. So I'll try to be 5 minutes now. Good. Hooray. So what we were doing at the hackathon relates to TEAS, which is why I'm here. It's part of a project in IETF, which is an open source group for TerraFlow SDN. And this is a cloud native controller. It's an open source project, and the intention is scalable, flexible, extensible, etc., etc. Has its origins in an EU research project called TerraFlow, and you can have a look at that link. The project's almost at an end, but as a research project, which is partly why we've moved everything into IETF and getting bigger, wider support. It's intended so to produce a controller that controls multiple technologies and uses standardized protocols and interfaces. So from a hardware point of view, it's sort of IP over WDM, and it's meant to include security and interdomain. At the northbound interface, we have currently L2 VPN, so that's the L2 service model and the L2 network model. And we're adding in the slice framework and other IETF service models. At the bottom, we're looking at a number of southbound protocols. So this should actually, and doesn't include IETF device models as well. And that's extending then in the future to some of the inventory work that's starting here, especially in CCAMP, and optical device models. It's not intended to become product. It's definitely a proof of concept. It's how do you put all the Yang models together? How might you structure an SDN controller to do all this? And people seem to be quite interested in this from the perspective of how might we specify what we want from a product? How can we point at the open source stuff and say, well, we want that function and not that function? Obviously, everybody's invited to come and play in the IETF project or look at the GitHub. Next slide. The picture here is intended to show, yeah, we can control, or we intend to be able to control quite a lot of stuff from this. And our TEAS relationship here is on the northbound of the SDN controller up to maybe an orchestrator using a number of different models, but adding in at the moment the slice service controller. Dan has put himself in the queue, which is probably to completely correct me.
No, Daniel King. I'm just wondering why we have not added to the data tracker, actually, for some of these documents, a reference to the GitHub for this project, because I would imagine that people might find it quite useful these days to find implementations. And that's a feature that doesn't seem to get used that often. I think it's a flag when you have one of these a working group document, you can add additional properties, and then you can have a GitHub flag with the repository name.
So I'll have to look, but I think those flags are for documents. And the ones for projects and other related work is a little different. And there are times that people will collect references to implementations, and sometimes that turns into product marketing. And so there's a slippery slope there that we've tried to avoid in the past. But it's not that it's against process or anything. It's just, it's this.
So alternatively, maybe implementation section.
And we have a wiki?
Mm-hmm. Yeah.
Sorry.
No, but definitely it exists. This field in the data tracker, in the document, there is some sort of field that you can add these reference things. It exists. Okay. So another different thing is how we want to use them.
Okay, we should look at that, definitely.
Yeah, Charles Eckel, just to clarify on that. Yeah, there's additional resources is the thing in the data tracker. And within additional resources, there's various tags. One to like point to the GitHub document where you're collaborating on the draft, but another one is the related implementations, and that would work well here. And in the case it's a working group document, it's actually only the chairs can add it. So basically people can ask, you can request, and then you can do a little sanity checking. One of the things we're trying to do, actually, there's a draft that goes into more detail on this, and we're trying to add some guidance for what the working group chairs should look for and how they should judge whether this is a marketing thing that should never be there or a really useful related implementation that should be added. So we want to try to provide that guidance so that we take a little bit of the burden and off of the working group chair, so you can just use that. So if anyone has any suggestions about things that they think should be provided in that guidance, let me know and I'll put it in the draft.
If you don't mind sending me personally, or maybe the chairs, a pointer to that.
Okay.
That'd be great.
Sure.
Thank you.
Will do.
And while Charles is here, thank you for organizing the hackathon at which we did this.
Yeah, so thank you, Chair, for inviting me to make this presentation about the that I have made already in the OPSA working group. So I modified slightly so that it can be adjusted to the what we are doing here in TEAS. Next slide, please. Yeah, so just for in the background, why we are talking about the SAPs. This is basically because in the framework document we have about the slicing, we specifically said that an SDP can be abstracted as a SAP for management purposes, but also for configuration systems. The next slide, please. So what is a SAP? A SAP is currently a network reference point in which the services can be delivered or are being delivered to the customers. They can be present before or during the service provision itself. It can be bound to one or multiple services. We have already, for example, in the SAP service, a given type in which that you can set, and then you have all the slice topology, for example, if you will. And then the SAPs, because they are a reference at the network side, they are attached to a customer side using what we call the dedicated and logical construct that we call the attachment sequence. The attachment sequence, they are not just a dummy link as that can be per se. This is something which is really more complex than that. They include a lot of bunch of information there. Layer 2, layer 3, address assessment, static information, and also some security and UM and so on. And the same SAP, it can be bound to multiple, I would say, to multiple peer SAPs using one or multiple attachment circuits. And then this attachment circuits, when you build them, you need to refer to something which is underlying. This is the physical connectivity, which is the bearers. So the bearers can be of various types. This can be wireless, wireline, and so on. So what we are trying here to do is not to change the terminology which is used in other contexts in RFC. We are just living with that, and we are building the story based on this concept. Next slide, please. So one of the problems that we have seen in various, I would say, service models is that people, they are, I would say, making a lot of assumptions or had an assumption about the attachment circuit, how it is done. Some of them are really, I would say, inaccurate. And this limits the applicability of the services themselves, if not incorrect plugin of the service into in real networks. Some of the service models tries to overload some of the concepts, for example, the peer sub ID, which I would say led to a lack of interoperability between when we map between the service into the network. There's also this problem of lack of consistency, because if each service model defines its own structure of the attachment circuits, we end up with something which is really, I would say, inconsistent. There is difficulty to map the pieces between various service model when we go into the configuration and actual control in the network. The last two points, they are really related to the way also we are modeling the services. Is today, if you want to control your attachment circuits, you have first to create the service, while this is not how the operations are done in some of the network. Some of the networks, they first create the attachment circuits and then they bind the service. So there's a lack of flexibility in the way we are controlling and attaching the services there. The last one, this is just specific to the OPSA working group. We have a very focused scope for the SAP. We don't have the binding between the SAPs and the attachment circuits. So there's something that we need to complete for this work. Next slide, please. So as I would say, in order to solve many of the issues that was listed in the previous slide, we are coming with at least three models there. The first one is the AC common model. This one is a standard library. So all the people who are working attachment circuits, they can just go into that model, they pick what they want, and then this is the first starting point. The second service the second model is the attachment circuit as a service. This one, it's really used to control directly the attachment circuits. And in this model, we adopted a strategy that we don't make an assumption of how this can be used by the other services. So if you want to separate your service provisioning versus your attachment circuit provisioning, you can do it. And for this one, we are exposing references that you can use when you are placing your service request. The other one, if a service model, for whatever reason that is specific to that service model, they want to include attachment circuits, we are providing reusable grouping for them, so they are invited to reuse this model for the sake of consistency again. The last and the last, I would say, model we have there is the network side. So when we go for the applicability of for the network slicing, so this is just a simple, I would say, architectural point of view story for various segments there, and how we can make use of the various, I would say, data models can be exposed by the controller to the consumers of this information. It can be the mobile network orchestration or whatever other orchestration that you can have in your own deployment. And this information will be given to the network service controller. So the network service controller can use, for example, the attachment circuit to set up the circuits between the DP and the peer customer devices, and this slice for within the DP themselves. Next slide, please. So this is just an example of a simple slicing example in which you have, I would say, a network, two Ps, and in one side you have a site, you have a gateway or a CE, and you have a cluster of network functions. These functions, they have in there a set of IP addresses that are used that are different than the one which is used in attachment circuits. And the other side, you have another site which is connected using a dynamic routing protocol. So next slide, please. So this is an example of how we can set up the attachment circuits. For example, for the first one, once you have the layer 2, the layer 3, and the static IP addresses. And the next slide, we show how we can make the association between the attachment circuit itself, the underlying bearer, and the BGP control station that we can establish between the P and the peer device. Next slide, please. So once you have set up your attachment circuit, the first one, for example here, the previous one, then when you will set your slice service request, then you just need to characterize your service and then just add a pointer to the attachment circuits that in which you will terminate your slicing service. Next slide, please. So this is a summary of what the rationale we are trying to describe here is that for the at least for the network slicing service interface, it will be really good that this is really restricted to do what is specific to the network slicing, and then we use the attachment circuit related material in order to factorize this I would say these features among all the service models themselves, and then in order to bind, I would say, the attachment circuits into the service, just make use of the references that are exposed in this various attachment circuits. And for example, if there's a new feature which is defined, for example, as a new technology to establish your, for example, as an attachment circuit, let it be GMPLS or MPLS or etc. that you use in your own deployments, you don't need to augment your service model. You just need to do it in the attachment circuits, and then all the service models will just use them for free and immediately. And that's the end of the presentation.
Thank you very much, Med. So any comments? Because you still have some time for questions.
So for people who want to hear more, Ops working group, right?
Yeah.
Ops area working group.
Exactly, yeah.
Okay, great, thank you.
Yes, here the important thing is how to relate this work with the existing drafts. Here we saw a lot of material of slicing. I hope that you are collaborating with the colleagues so you can work together.
Exactly.
Okay.
All right, last one. Tony.
Which is number 12.
Konnichiwa. Hi, this is Tony Lee. I'm be talking about tactical traffic engineering. Colby Barth was scheduled to present, but he's not showing up, so you get the B team. Next slide, please. So what we're out to do is to deal with tactical resource depletion. Now, historically, we've been pretty good about working towards doing things strategically. We collect a lot of data about our traffic utilization, and we feed it into some optimization routines, and it cranks on interesting paths and cranks away for quite a while. And then out comes a large set of path placements. And we feed this into RSVP or into SRTE, and it lays down our network paths. All well and good, except in real life, stuff happens. You might get an excess of traffic, you might get link failures, node failures, you might get presidential motorcades, who knows? Anyhow, things go wrong, and all of the wonderful engineering that we go put into these things may not actually have the results that we want. And so you can end up with congestion in your network. Now, historically, what happens at this point is that somebody in the NOC reaches in and does something manually and ugly, and something as gross as tweak an IGP metric. And this may or may not do what you want. It may overreact. It may be really, really ugly. So what we're out to do is to do something in a short-term time frame that adjusts traffic to alleviate congestion. Next slide, please. So what we're out to do is try to do something that's kind of in real time. We want to recognize congestion when it happens. We want to take a look at the backup paths that we have available in the FIB, and we want to enable some of those to take some of the traffic load off, and then alleviate the congestion on our protected link. And we'll talk a little bit about flow distribution. Next slide. I'm going kind of fast here because we're running out of time. If you're very interested in this topic, we'll be giving the same talk again in the routing working group in the next session. Recognizing, previous slide, please. Recognizing congestion is pretty straightforward. We look at some congestion thresholds. These are configurable. We sample the interface. We want those samples to exceed the thresholds, either high or low, for some number of iterations, so that we've got a consistent and clear indication that it's consistent congestion, and we don't want to oscillate. So if it's high, we're going to try to shed some load. If it's low, then we're going to undo any of the load shedding we've done. Next slide. In the fib, we have IPv4 or IPv6 entries. We could also do this with labels. We can conceivably do this for any kind of backup path. So TI, LFA, LFA, FRR, whatever it is we have available that is a potential backup path that is loop-free and avoids the link that we're trying to protect. And then when we see that path and see congestion, we're going to activate some set of those paths, and then that's going to turn into an ECMP situation, equal cost multipath, and hopefully divert some fraction of the traffic. Next slide. When we do select a flow and shift it to be ECMP, we call that activation, and that happens to shed load. And then when we see that the load on the primary link has come back down, we deactivate prefixes to bring traffic back onto the primary path. Next slide, please. When we do this, it's going to have an impact on the network. We are shifting load onto our TLA LFA paths. Now, assuming you've done a decent job of network engineering and considering your backup paths, there should be spare capacity available there. This is a presumption. If you're throwing backup paths around and are not engineering the bandwidth for them, well, you're going to very much get a surprise if and when your primary link actually just fails, out and out fails. So that's going to be a problem. However, if you've got multiple places of congestion happening concurrently, and TT is shifting multiple situations, trying to fix many things in your hot network at the same time, could it conceivably create further congestion? Absolutely. Can that further congestion cause more TT activations? Absolutely. So there is a potential for things just shifting and shifting and shifting and not helping anything. The presumption here is that you do have some spare capacity. And if you don't, this is probably not the right feature. Next slide. What is it that we want to load shed? Well, we want to take a look and try to figure out what are the right paths to move. And this is not a trivial decision because we want to actually not change too many things if we don't have to. Every time we do activate or deactivate a prefix, we have to remember that the traffic is taking a hit. We are triggering slow start on all the traffic that's moving. So we really don't want to do this if we don't have to. And so we want to select the right paths. We've played around with this a little bit. We've got multiple strategies that we are working with. We don't claim to have a perfect answer at this point. Next slide. That gives me exactly 1 minute for questions. Adrian.
Hi, Adrian Farrell. Thanks, Tony. Interesting stuff. I just put a link in the chat to the TE document that is in the AD's queue, but there's a little section in there that mentions tactical TE, and I'd appreciate it if you could just check that that's consistent with what you're talking about.
Thank you. I'll look at that.
We don't see anybody else at the mic. We do see that you are presenting this again in RTGWG. Okay, seems like there's somebody else at the queue. But yeah, we haven't talked, while before I bring in Andrew, we haven't talked to the RTG, TWG chairs about what would be a reasonable home for this. We'll have that discussion and make that call. Andrew?
Hopefully you guys can hear me okay. I was just wondering, do you see TTE playing a role in a network that also has a live controller in use at the same time?
That is entirely possible. It very much depends on exactly what your controller is doing. Obviously, if your controller is set up to do short-term engineering that might have some very, very bad interactions, I would not recommend that. However,
Yeah,
if your controller is set up for much longer term, a typical thing some folks used to do was to optimize once a day. And if you're operating your controller on those time frames, then this is perfect.
Gotcha. That's it. Yeah, that's exactly what was crossing my mind was if you had a controller doing, let's say, live optimization at the same time, TTE would potentially kind of skew its ability to kind of optimize at the same time. You kind of have two brains in that point kind of fighting each other in a way. Okay, cool. Thanks.
Yeah, no network can serve two masters.
Thanks, Tony. That brings us to the end of the second session. We will see you all in San Francisco, and thanks for 2 great sessions.
Thank you very much.
Delegate.